Hello there and welcome back. Tonight we're going to take a journey not just through time, but through the powerful rhythms of the Earth itself. The rise and fall of temperatures, the waxing and waning of glaciers, the breath of forests, and the drying of oceans. These great transformations have sculpted every living thing that ever walked, crawled, swam, or bloomed upon our planet. As you listen, you'll find yourself drifting across epochs, following the subtle yet massive changes in Earth's climate that brought life to its knees and raised it up again. Imagine the world as a canvas, and climate as the great painter, brushing over mountains, oceans, and the destinies of species. Now let's begin our journey, deep in the distant past, when Earth's face was unfamiliar and its breath was icy and strange. You open your eyes to a world you wouldn't recognize. There are no continents as you know them. The air is thin and cold, and above you the sun is faint and distant, casting pale light across an endless white expanse. You are standing on the surface of a frozen planet, a place some scientists believe may have once been entirely encased in ice. This is Earth nearly 700 million years ago, during a mysterious and haunting time often called Snowball Earth. It's a name that captures the unimaginable scale of cold, glaciers stretching from the poles all the way to the equator, oceans covered in thick ice, and a silence that feels almost eternal. But how could this happen? Why would Earth, which lies in the so-called Goldilocks zone, not too hot, not too cold, turn into a snow-covered marble drifting through space? To answer that, we need to go even further back. Picture the Earth after its early, violent birth, after the collisions that shaped the moon, after the seething oceans of lava began to cool. Over millions of years, the planet settled into a delicate balance of atmosphere and temperature. Volcanic gases thickened the air, water gathered in oceans. Primitive single-celled organisms began to bubble and breathe beneath the waves. Some of those organisms, tiny cyanobacteria, had a talent that would change everything: photosynthesis. With sunlight and carbon dioxide, they made food and gave off oxygen. At first, that oxygen transformed Earth's chemistry, but eventually it filled the skies, and this sudden burst of oxygen changed more than just biology. It shifted the planet's climate itself. Oxygen reacted with methane, a powerful greenhouse gas, reducing the blanket that had kept Earth warm. The planet cooled. Ice crept across continents. And suddenly that cooling spiraled out of control. You step across a frozen shoreline where the sea meets the land, but instead of waves, you see nothing but solid ice stretching to the horizon. Beneath this ice, in darkness, life still clings on, barely. Small, hardy cells live near hydrothermal vents on the seafloor, feeding off chemical energy instead of sunlight. They are survivors in a world where the sun's warmth barely reaches. Above the ice, the landscape is silent. Winds whistle across the white plains, but there are no animals, no plants, only stillness. Even the sky seems quiet, covered in a thin layer of cloud that traps what little warmth remains. But deep below, something is stirring. Beneath the continents, magma shifts. Volcanoes begin to erupt, one by one, releasing carbon dioxide back into the atmosphere. Slowly, over millions of years, this CO2 builds up again. It thickens the air. The greenhouse effect returns. Temperatures inch upward, and then one day, the ice begins to melt. Imagine standing in this moment. At first, the world is waking up. From the perspective of life, this change is momentous. For hundreds of thousands, maybe millions of years, organisms have been surviving in near darkness. Now, with the ice receding, new habitats emerge. Oceans circulate, nutrients flow. Sunlight penetrates deeper into water, and life begins to bloom. But we are still far from the vibrant world you know. Multicellular creatures remain primitive. They drift in oceans as tiny filaments and blobs. No fish yet, no shells, just a slow unfolding of complexity, a preparation for the bursts of life that will soon follow. As the planet warms, Earth begins to breathe again. Glaciers retreat toward the poles, rain falls, rivers flow. The air thickens with water vapor and carbon. The quiet is replaced by motion. And through all of it, climate, invisible, powerful, ancient, continues its dance, setting the stage for everything to come. In this tale of fire and ice, we see Earth's first grand lesson, that climate can shape the destiny of life. And just as the deep freeze nearly silenced the world, the warming that followed whispered life back into motion. Now, as we step out of this frozen chapter, a new scene awaits, one filled with strange creatures, teeming oceans, and a burst of evolution like no other. It is a time called the Cambrian. The chill lingers as you move forward in time, deeper into the Proterozoic eon. The memory of Earth blanketed in white has not yet faded, because it is not over. In fact, the planet enters this deep freeze more than once. These massive global glaciations, the Sturtian and the Marinoan, grip the Earth like a hand of ice, separated by millions of years, yet remarkably similar in their frozen fury. Imagine looking down at Earth from space. You see no green, no blue, only white. It's as though someone has painted the planet in layers of frost and silence. Ice stretches from pole to equator. Thick glaciers blanket the continents. Even tropical latitudes are frozen over. It's one of the most extreme climate episodes the planet has ever known. But how do we know this happened? As you look into ancient rocks that were once muddy sea floors and icy mountainsides, you find the fingerprints of glaciers near the equator. These rocks are called tillites, formed when ice grinds up the land beneath it, leaving behind unsorted debris. And when scientists find these deposits far from the modern poles, they realize something astonishing. Glaciers once reached nearly every part of the globe. It's a humbling realization that Earth's climate has not always been stable or gentle, that entire oceans once froze over, that life persisted in the shadows of catastrophe. Beneath the ice, you descend into a sunless world, a world of supercooled oceans, locked under kilometers of frozen crust. But here, in the crushing pressure and bitter cold, life carries on. Tiny microbial mats, layered like ancient carpets, cluster near hydrothermal vents. These vents, cracks in the sea floor where heat and minerals pour from Earth's interior, are warm oases in a frigid sea. The organisms here are chemotrophs, beings that eat chemicals instead of light. They feast on sulfur and iron, building simple structures in the dark. Their ancestors have seen this before. They have survived countless shifts, adapted to poison, drought, heat, and now, cold. And they will survive this, too. Some scientists believe that life may have hidden away in brine channels, pockets of salty water trapped within sea ice, where the freezing point is lower and temperatures stay just above lethal. Others suggest that cracks in the ice allowed sunlight to filter through, enough to fuel photosynthetic life just below the surface. No matter how, the miracle is that life endures. But for the planet, this stasis cannot last forever. As volcanoes continue to release carbon dioxide into the atmosphere, a dangerous imbalance grows. With the Earth's surface frozen, carbon dioxide is not removed from the atmosphere the way it usually would be, through weathering of rocks and photosynthesis. So, year after year, the gas accumulates. Like invisible insulation, it traps heat from the sun, very slowly warming the surface. And then it happens. At first, you hear it, the crack of melting ice, echoing across a frozen valley. Then, the rush of meltwater, streaming across rock for the first time in millennia. The glaciers groan and shift, their weight softens, ice sheets thin. Pools form on their surfaces and trickle downward, lubricating their bases. Suddenly, glaciers surge, sliding faster, breaking apart, collapsing into the oceans. And when that dark ocean surface is revealed, it drinks in the sun's heat with ferocious speed. A feedback loop begins. The more ice that melts, the more sunlight is absorbed, and the faster the planet warms. Before long, the Earth shifts from frozen tomb to furnace. In geologic time, this thaw is fast, a few million years at most, and the consequences are staggering. Massive floods wash across continents, ancient riverbeds reform, sea levels rise dramatically as glaciers vanish. The atmosphere, now thick with carbon dioxide, becomes supercharged. Temperatures soar. From deep freeze to hothouse, the pendulum has swung far, and in the oceans, this change is like a second Genesis. Nutrients, long trapped in ice or in stagnant cold water, now flow freely. Upwelling currents bring phosphorus and iron from the seafloor into sunlit waters. Microbial life responds in a flourish. Photosynthesizers bloom across the seas in massive algae blooms. Oxygen levels rise. Life becomes more energetic. Some lineages grow larger, more complex, more organized. The snowball episodes may have nearly wiped the slate clean, but instead, they prepared the world for something new. You watch as the first glimmers of multicellular life begin to stir. These creatures are not yet animals as we know them, but they are no longer just single cells. They are colonies, sheets, or tubes, like the ediacarans that will soon follow, drifting slowly in nutrient-rich water, each one a tiny experiment in complexity. It's as though the stress of surviving such an extreme world has forged resilience into the very structure of life. And now, in the warmth that follows the storm, life is ready to grow again. Some scientists believe the Snowball Earth episodes were essential, a kind of purification or reboot that paved the way for the explosion of complex life in the Cambrian that would soon follow. Without these icy trials, evolution might have wandered down different paths, but with them, it was forced to innovate, adapt, and become stronger. The air warms as you breathe it in, and the ground beneath you is no longer locked in frost. Rain falls gently onto new rivers. Oceans pulse with energy. The world has turned a page, and ahead lies one of the most breathtaking chapters in Earth's story, a time when life takes a deep breath and leaps into complexity. The Cambrian explosion is about to begin. You feel it before you see it. The hush of melting glaciers, the warm breeze returning to a world long held in winter's grasp. The age of ice is ending. Slowly, and then all at once, Earth awakens. You are standing now on a vast plain where ice has only recently receded. The ground is uneven, scoured by the weight of retreating glaciers. In some places, meltwater pools in newly carved valleys. The air is heavier, moister, carrying the scent of wet stone and warming soil. And though the skies are still pale, there's a golden tint in the light, a sign that the atmosphere is changing, swelling again with gases that trap the sun's warmth. This is the Great Thaw. Volcanic eruptions, silent and steady over millions of years, have built up a thick blanket of carbon dioxide. With Earth's surface frozen and unable to absorb this gas, the concentration rose unchecked. Now that trapped heat has finally won the battle. The ice collapses in stages, at first slowly, releasing icy rivers and cold winds, then faster as entire ice shelves break apart. What follows is one of the most intense warming events in Earth's history. Temperatures shoot up, the seas boil with new energy, and all around the globe, ecosystems begin again, from near nothing. This period, known as the aftermath of the Marian glaciation, marks more than just the end of a frozen age. It is the dawn of a new one, and it lays the foundation for life, to grow beyond anything Earth has ever known. You walk now through shallow seas that have returned to the margins of continents. The waters are tinged with green and gold, rich with plankton and algae. These are among the first visible signs of rebounding life. They float in vast blooms, their cells filled with chlorophyll, their structures simple yet vital. They feed on sunlight and nutrients released from freshly eroded rocks, and in turn, they release oxygen, filling the ocean and air with a breath of possibility. The warming of Earth doesn't just thaw the planet, it stirs the oceans. For the first time in ages, the waters mix deeply. Cold bottom waters rise to the surface, carrying iron and phosphorus. These nutrients fuel an explosion of microbial activity. And with that comes a rising oxygen level, a second, quieter revolution that will prove just as crucial as the melting of the ice. Beneath the waves, life becomes more adventurous. You spot unfamiliar shapes drifting in the currents. They are not quite animals, but they are more than bacteria. These are the ancestors of complex life. Colonies of cells that cooperate, share resources, and specialize in different tasks. Some form tube-like bodies, others spread like lace across the sea floor. They do not hunt, yet they move, sensing light, currents, perhaps even chemicals in the water. They are preparing for something more. This is the Ediacaran period, the final chapter of the Proterozoic eon. A time still cloaked in mystery, when life began to test the limits of form and function. Fossils from this time are rare but astonishing. Impressions of soft-bodied creatures, some like discs, others shaped like feathers, fronds, or leaves, show that nature was experimenting. These beings had no bones, no shells, no hard parts at all. But they grew large, some more than a meter long, and they sprawled across the ocean floors like strange carpets of living fabric. On a quiet slope beneath the sea, you pause beside one of these creatures. It lies still, anchored to the seafloor. Its body is leaf-shaped, its surface rippled. There is no mouth, no eyes. It feeds by absorbing nutrients directly through its skin, drawing energy from the water. It is passive, gentle, and entirely alien to anything that exists today. And yet, it represents a crucial step in life's story, the leap from single-celled simplicity to multicellular potential. As the Ediacaran world continues to evolve, new forms emerge. Some glide, some pulse, some even burrow. Their energy is limited, their designs fragile, but their presence signals something extraordinary. Life is no longer just surviving. It's beginning to thrive. Meanwhile, above the seas, the continents themselves are changing. With the end of global glaciation, erosion returns. Rain falls steadily on young mountains, washing minerals into rivers and into the sea. This flow of nutrients enriches marine environments, supporting ever more life. And it may be during this time that Earth's first rudimentary food chains begin to form. Algae feeding simple grazers, grazers becoming prey to slightly more complex creatures. For the first time, ecosystems are forming layers. Roles are being defined: producers, consumers, decomposers. A hierarchy that will become the framework for all future biology. As you rise above the ocean and look across the planet, it feels like a world rediscovering itself. The skies are clearer. The oceans shimmer with new life. And the continents, though barren and rocky, are slowly being shaped by wind, rain, and the quiet footsteps of the future. It is hard to imagine how recently this world lay in frozen silence. And yet, here it stands, a planet reborn. From this newfound complexity will arise challenges: competition, predation, extinction, but also dazzling creativity. And soon a new era will begin, one in which life, driven by oxygen and change, explodes into forms and behaviors the world has never seen before. Next, we will step into that pivotal age, a chapter so filled with innovation that scientists call it an explosion. It is the Cambrian period, and it is where animals begin their grand debut. The waters shimmer with sunlight as you step into the Cambrian period, a time of warmth, movement, and astonishing innovation. Nearly 540 million years ago, Earth enters an era like no other in its deep past. With the ice ages behind and oceans rich with nutrients, life finally finds the freedom to flourish in form, function, and diversity. You find yourself in a shallow sea, clear and inviting, stretching over a continental shelf. The water is warm, almost silky against the skin, and filled with tiny drifting particles. This sea is not just a place of life, it is life's grand stage. Beneath the gentle waves you glimpse strange shapes, darting, crawling, drifting. This is the moment when animals, true animals, begin to populate the world in all their wondrous complexity. The Cambrian explosion, as it's now called, is less of a sudden blast and more of a steady, breathtaking bloom. Over just 20 to 25 million years, a heartbeat in geological terms, the fossil record fills with an abundance of new creatures: trilobites, brachiopods, worms, sponges, and early ancestors of every major group of animals alive today. And this burst of diversity is not just in bodies, but in behaviors. You peer into the sand and spot the trail of a worm-like creature digging through the sediment, burrowing in search of food or shelter. Next to it glides a sleek, paddle-shaped animal, an early swimmer with rows of flapping lobes. And above it all drifts a jelly-like blob, pulsing gently as it floats in the current. What caused this explosion of form? The climate, for one, plays a crucial role. Earth is now in a greenhouse phase. The atmosphere is warm and stable. Polar ice is nearly gone, and sea levels are high. These warm, shallow seas cover vast parts of the continents, offering the perfect cradle for life to diversify. But it's not just the warmth. It's what the warmth allowed to happen. With glaciers melted and oceans circulating freely, nutrients surge into the seas. Algae flourish, releasing oxygen through photosynthesis. And that oxygen makes a world of difference. For the first time, animals can grow larger, move faster, and develop more intricate body systems. Muscles, nervous systems, digestive tracts, all become possible because the energy demands can now be met. It's in this moment that Earth becomes a place of movement. You crouch near a reef-like structure, not made of corals, but sponges and microbial mats, and spot trilobites scuttling across its surface. These iconic creatures, with their armored plates and many legs, dominate the Cambrian oceans. They come in dozens of varieties, some with long spines, others with wide, flattened bodies. Their compound eyes glint like crystals. They are among the first creatures with complex vision. Vision. The gift of sight. It may be this evolutionary leap, the ability to see and respond to the world, that fuels a chain reaction. With eyes come hunters, and with hunters come prey. Suddenly, life is not just passive. It is reactive, strategic, alert. Some creatures grow spikes or hard shells. Others develop burrows to hide. Some begin to swim with speed and purpose. This dynamic, predator and prey, marks the beginning of ecological arms races. Evolution accelerates. Each adaptation inspires a counter-adaptation. It's nature's first great innovation boom. Drifting through the water, you pass a bizarre creature, Anomalocaris, the abnormal shrimp. It's large, perhaps a meter long, with wide eyes, grasping limbs, and a circular mouth filled with jagged plates. It's one of the first apex predators, and its prey? Mostly trilobites, whose fossilized remains sometimes show scars and bite marks, the evidence of early battles beneath the sea. But not all Cambrian life is fierce. Many are still soft-bodied, delicate, peaceful. Some lie motionless, filtering nutrients from water. Others glide through the silt, feeding on organic particles. Their bodies show remarkable variety: radial symmetry, bilateral symmetry, coiled forms, segmented limbs, and perhaps most important of all, some of them begin to form the early blueprints of vertebrates, creatures with a central nerve cord, the ancestors of fish, and eventually, us. In a quiet alcove, you notice a creature, barely a few centimeters long. Its body is translucent, shaped like a lance, with faint lines running down its side, segmented muscles that hint at motion. This is Pikaia, a small, worm-like animal that may be one of the earliest chordates. It swims not with flailing limbs, but with coordinated muscle waves rippling like a ribbon in water. Though humble in appearance, Pikaia carries the genes of greatness. From creatures like this will arise jawless fish, then bony fish, then amphibians, reptiles, mammals, a lineage that stretches forward through time to all vertebrate animals today. You linger in the warm currents, watching this world unfold. The Cambrian Sea is not just a moment in Earth's history. It is a transformation, a shift from simplicity to structure, from static to dynamic, from smallness to scale. It's also the beginning of death on a larger scale. With complexity comes vulnerability. Creatures are no longer eternal microbes, but beings with lifespans, injuries, and predators. But in that risk lies beauty, the beauty of motion, of interaction, of purpose. The Cambrian warmth has opened a door. Earth is no longer a world of silent drifting. It is a theater of activity, a planet alive with possibility. And as you rise from the sea and gaze toward the coastlines, something else stirs, not in the oceans, but on the edge of the land. A few microbial mats hug the shoreline. Tiny green films creep across moist rocks. It's subtle but unmistakable. Life is preparing to step out of the water. The next stage will bring forests, insects, and towering trees. A green revolution that will transform Earth forever. You now find yourself beneath a sun that burns a little warmer, beside a coastline no longer barren. The time is the Devonian period, around 400 million years ago, and the Earth has changed again. The oceans still teem with life, but something astonishing is unfolding on land. The silence of rock and wind is being broken by the first whispers of green. You stand in a valley where moisture clings to the air. Around you, the ground is soft and dark with new soil. Small, spindly plants grow in clusters, their stems stretching upward as if reaching for something they cannot name. These are not yet trees as you know them. They are primitive. No flowers, no leaves. Just simple stalks. But they are alive, and they breathe. The air is different now. Oxygen levels are climbing, fueled by photosynthesis from these land pioneers. Carbon dioxide, once dominant, is being drawn from the sky and locked into plant matter and soil. Slowly, the atmosphere shifts, and as plants rise, they change the land. Their roots dig into the earth, breaking rock, forming channels. Water gathers. Rivers meander. Rain no longer rushes straight to the sea. It lingers, seeps, nourishes. Soils form. Landscapes soften. You walk through these early forests, calm, quiet groves of lycophytes and ferns. The tallest of them might reach 2 meters, but they are ambitious. Over time, they'll evolve into towering giants. The first real trees, like Archaeopteris, with broad crowns and woody trunks. Their trunks are remarkable. For the first time in Earth's history, plant bodies grow thick, hard, and tall. Wood, a structure of strength and storage, allows plants to reach above their neighbors, to compete for sunlight, to live longer. And with these forests come shadows, cool spaces, microclimates. The land becomes more varied, more alive. But while life stretches upward on land, the oceans remain the center of richness and diversity. You dive into a reef system unlike any today. Built not by coral, but by ancient stromatoporoids and tabulate corals now extinct. These reefs are vibrant, home to armored fish with bony plates and toothless mouths, and others with graceful fins and powerful jaws. The Devonian is often called the Age of Fishes, and for good reason. Here swims Dunkleosteus, a fearsome predator with a body over 30 feet long, sheathed in thick bone, and jaws that snap with tremendous force. It roams the reef edges, hunting smaller fish that dart and shimmer like living jewels. Nearby, sharks, still primitive by modern standards, glide in deeper waters. Their bodies are sleeker, built for speed. They are part of a growing trend: more mobility, better sensory systems, stronger muscles. Life in a sea is becoming fast and competitive. You peer into shallow waters and spot something curious. A lobe-finned fish, slow but purposeful, using its strong fins to push along the bottom. This is tiktaalik, not yet a land animal, but more than a fish. Its limbs are jointed, its eyes face forward. It can lift itself, breathe air, support its own weight, at least for a short time. This is no ordinary fish. This is a scout, an explorer. Its descendants will one day walk. Back on land, insects have appeared. Small, wingless ones at first, primitive relatives of silverfish and springtails. Then, with time, others grow wings. Some fossilized dragonflies of the Carboniferous, just beyond the Devonian, will reach wingspans of over 2 feet, thriving in the high-oxygen world created by plants. Everywhere you look, the balance is changing. Photosynthesis from massive forests draws down carbon dioxide. This process cools the planet. Glaciers begin to form again in high latitudes. Oxygen levels rise. Animals grow larger, more active, more reliant on high-energy metabolisms. But there's a catch. These forests, for all their beauty and life-giving gifts, also store massive amounts of carbon in their trunks, leaves, and roots. When they die and fall, they often do not fully decay. Their remains are buried, peat, then coal. The carbon they removed from the air is locked away underground, and Earth, ever sensitive to imbalance, begins to tip again. Toward the end of the Devonian, the climate begins to shift. Sea levels fall. Oxygen levels in the oceans drop. Marine ecosystems falter. Entire reef systems collapse. Many species, especially in shallow waters, vanish. It's not a single disaster, but a long, drawn-out series of stresses. It becomes one of Earth's 5 major extinction events. You float above a Devonian coastline during this decline. The forests still stand. The air is still rich. But in the oceans below, life is thinning. Where once fish thrived, now there is silence. Where reefs buzzed with color, now only rubble remains. It is a solemn reminder. Life and climate are always entwined. The rise of forests, so vital to the growth of life on land, may also have contributed to devastation in the seas. But even as this chapter closes, it leaves behind a legacy. Rooted plants, walking vertebrates, complex ecosystems, and cycles of carbon and oxygen that will shape Earth forever. You turn away from the fading reefs and look once more to the land. There, in the muddy edges of ancient streams, creatures are crawling. Awkward, slow, curious. They are the first tetrapods. They do not yet own the land, but they are trying, and soon they will succeed. And as they do, a new world will emerge, one where life moves beyond water, forests grow tall and tangled, and the planet prepares for a vast new challenge, a cycle of swamps and carbon that will cool Earth once again. The ground beneath your feet is soft, damp, and thick with fallen leaves and ancient peat. You've arrived in the Carboniferous period, about 300 million years ago, and the air is like a breath from a greenhouse, dense, humid, and heavy with the scent of growing things. Towering trees loom above, their trunks covered in scales, their canopies layered in ferns and feathered fronds. This is Earth at its greenest, and its most oxygen-rich. All around you the land hums with life. You stand in a swamp forest that seems to stretch endlessly. This is not the familiar forest of today, with flowers and pine needles. Instead, this is a world of club mosses the size of buildings, of horsetails taller than houses, and of seed ferns sprawling across the ground. Plants dominate everything. They cover the land so thoroughly that the sky is barely visible through the thick foliage. These trees have no seeds, no flowers, and no true wood. They grow quickly and die just as fast. When they fall, they sink into the waterlogged ground where oxygen is scarce and decay is slow. Over time, their remains pile up in thick, spongy layers, peat, pressed by the weight of generations. And as millions of years pass, that peat will harden into coal. You've entered the time when the Earth began burying its carbon. It's one of the most remarkable shifts in the planet's history. Before the Carboniferous, much of Earth's carbon was still circulating, in the air, in the oceans, in living organisms. But now, thanks to the evolution of vascular plants, which use lignin and cellulose to grow strong and tall, and thanks to swamps that trap their remains, carbon begins to vanish from the sky. And with less carbon dioxide in the atmosphere, something else happens. The planet begins to cool. You can feel it in the breeze that moves through the ferns. A freshness, a crispness that hints at coming change. Glaciers once again begin to form at the poles, especially in what is now the southern supercontinent of Gondwana. The ice spreads gradually but persistently. Sea levels begin to drop. The warm swamp forests start to fragment. But while they last, these carboniferous wetlands are home to vibrant, tangled ecosystems. In the undergrowth, giant insects crawl and buzz. You spot a dragonfly with wings as wide as your outstretched arms. Meganeura, a titan among insects, gliding slowly through the still air. On the ground below, millipedes longer than a human slither through damp moss. Amphibians, some the size of crocodiles, lounge at the edges of pools. Their skin is smooth, their bodies squat and muscular, their eyes ever watchful. In the trees, early reptiles begin to appear, creatures that no longer need to return to the water to lay eggs. With their amniotic eggs and tougher skins, they can venture deeper into the forest, higher into the canopy, farther from their watery origins. They are not yet dinosaurs, but they are on the path. And all the while, the plants grow. They grow with a purpose. Upward toward the sun, outward over the ground, downward into the soil. Their roots stabilize riverbanks. Their branches form layered habitats. Their leaves pump oxygen into the sky. Indeed, this is the peak of atmospheric oxygen in Earth's history. Some estimates suggest oxygen levels reached 30 to 35% during this time, nearly 50% higher than today. Fires flare more easily. Insects grow to unnatural sizes. Respiration is easier, allowing animals to thrive in unexpected ways. Yet the climate is not steady. Earth is never still. As carbon is pulled from the atmosphere and locked into cold beds, and as tectonic shifts rearrange continents, the balance tips. Cooling accelerates. Glacial cycles grow stronger. The great swamp forests, once unified, begin to shrink into isolated pockets. Some dry out. Others drown beneath rising groundwater. Ecosystems fragment. And with that fragmentation comes collapse. Species that once thrived in vast interconnected wetlands now find themselves trapped in shrinking islands of habitat. Specialized creatures disappear. The grand carboniferous forest begins to unravel. And yet, from this unraveling, something new emerges. You walk through a clearing where a river once flowed. Now the land is drier, hillier, patchworked with grass-like plants and hardy shrubs. In this changing environment, new kinds of reptiles appear. Creatures better suited to dry conditions with tougher eggs and stronger lungs. Some develop sail-like spines for thermoregulation. Others become burrowers or quick-footed hunters. Earth is preparing for another transition. The Carboniferous ends not in fire, but in frost and division. The swamps vanish, the forests thin. Glaciers claim the southern lands. Oxygen levels drop. Coal continues to form deep below, but the great cycle that began with endless plant growth is slowing down. Still, in the legacy of this era lies something profound. The carbon buried in these ancient forests, transformed into coal over eons, will one day reshape the world again when humans discover it and burn it in furnaces and engines. But for now, it lies silent beneath the earth, a memory of green abundance and quiet collapse. You step forward, feeling the planet shift once more. As the swamps give way to deserts and as reptiles rise in number and strength, Earth prepares for a new trial, one that will be even more devastating than the Devonian's decline. A warming, poisonous episode that will nearly end life itself. The next chapter is called The Great Diet. The air is dry now, tinged with dust and heat. You stand on the surface of Earth in the late Permian period, roughly 252 million years ago. What was once lush and swampy has become hard and sun-scorched. The forests have thinned, the insects have shrunk, and the animals that now roam the land are tough, scaled, and low to the ground, built for heat, dryness, and survival. The continents have merged into one massive landmass, Pangaea. This supercontinent stretches almost from pole to pole, creating vast interiors where rain rarely falls, and seasons swing between burning summers and bitter winters. The world is unified, but harsh. You feel the desolation in the air. Where forests once stretched across the land, now there are deserts and arid plains. Only scattered conifers and seed ferns remain, struggling to hold on. Amphibians, which once ruled the swamps, have retreated to wetter margins. Reptiles, particularly the therapsids, ancestors of mammals, dominate the land with toothy beaks, sail-like backs, and thick limbs. Despite the challenges, life still clings to Earth.
Some species thrive in the new climate. Burrowing reptiles, efficient walkers, and water-storing plants spread across the dry interior. In the oceans, coral-like reefs still grow, and fish swim in schools along continental shelves.
But this balance is fragile, and soon it will shatter. The catastrophe begins in what is now Siberia. Beneath the crust, a vast mantle plume pushes upward, a bulge of hot rock and magma that cracks open the land in a chain of apocalyptic eruptions. These are not single volcanoes, but flood basalts, massive lava flows that cover millions of square kilometers in layer after layer of basaltic rock. The Siberian traps, as they are now called, erupt continuously for nearly 1 million years. You stand on a high ridge and watch the lava pour across the land, lighting the sky with fire and smoke. The ground shakes, ash darkens the air, the sun dims behind clouds of sulfur dioxide and ash. Temperatures plummet at first. A volcanic winter. But this is only the beginning. With every eruption, not only lava but gases are released. Carbon dioxide, methane, sulfur compounds. At first, the sulfur cools the planet, but eventually, the greenhouse gases overwhelm it. Temperatures begin to rise. Then, they soar. It is one of the most extreme warming events in Earth's history. You can feel the shift in the oceans. Warmer waters hold less oxygen. The seas begin to stagnate. Currents slow. Life in shallow waters struggles. Coral reefs collapse. Shelled creatures, brachiopods, trilobites, ammonoids begin to vanish. As carbon dioxide continues to accumulate, the oceans turn more acidic. Shells dissolve. Microorganisms at the base of the food web weaken. And then something worse happens. Large-scale release of methane from undersea deposits. This superpotent greenhouse gas pushes temperatures even higher. Across the land, vegetation withers. Drought becomes relentless. Forests burn, and ash blackens the rivers. Acid rain falls, scorching what little greenery remains. Insects, resilient for hundreds of millions of years, face a global collapse. Even they cannot keep pace with the speed of change. You walk across a barren plain littered with bones and dust. Once vibrant ecosystems have vanished. Entire groups of animals, gorgonopsids, dicynodonts, and dozens more are gone. The air is hotter now, drier, thinner. The earth is wounded. This is the Great Dying, the Permian-Triassic extinction. It is the most severe extinction event in Earth's history. More than 90% of marine species go extinct. Nearly 70% of land species disappear. Forests collapse. Reefs vanish for tens of millions of years. Food webs disintegrate. For a moment, a geologic moment, it seems as though life itself may not recover. And yet, it does. You crouch beside a quiet burrow, Inside, a small lizard-like therapsid hides in the shade, surviving on roots and insects. It is no larger than a rabbit, but it carries something powerful: endurance. It can regulate its temperature. It can dig. It can wait. Such creatures, small, hardy, efficient, will inherit the earth. The oceans begin to stir again, slowly. New types of plankton appear. Some reefs reform in isolated patches. On land, new plants take root, seed-bearing ones with tough coats and deep roots. Reptiles diversify again. And within a few million years, the scars of the great dying begin to fade. But Earth is not the same. The world has been reset. From the wreckage, new ecosystems will form, and one group of reptiles, the archosaurs, will begin to rise in number. Among them will be the first ancestors of crocodiles, pterosaurs, and dinosaurs. The Earth has passed through fire and famine, through suffocating heat and poisoned seas, and yet life holds on. Fragile, yes. Changed, absolutely, but alive. And now, as the Permian ends and the Triassic begins, a new era is dawning, one that will bring walking giants, deep green forests, and a world reshaped by survivors. The world feels quiet now. Too quiet. The devastation of the Permian extinction still lingers like a long shadow across Earth's surface. The once rich seas are sparser, the forests are gone, and the land is eerily subdued. But listen closely. Beneath the silence, something is stirring. You've arrived in the Triassic period, roughly 250 to 200 million years ago. This is a time of healing, of slow but powerful recovery. Life has been knocked to its knees, but now it begins to stand again, reshaped, humbled, but ready to adapt. You walk across a vast plain, where red earth meets a pale sky. The climate is dry, the air thin, and the wind carries dust across the cracked surface. It's hot, especially in the interiors of Pangaea, where the supercontinent's massive size limits rainfall. There are no ice caps. The seasons are extreme. Yet somehow, even here, life is clawing its way back. Sparse vegetation dots the ground, hardy seed ferns, ginkgos, and conifers that can withstand long droughts. Their roots dig deep and their leaves are narrow to conserve water. There are no flowers, not yet, but green is returning to the land, and with it, animals emerge from the ashes. At first, it's the generalists, creatures that can eat anything, live anywhere, and reproduce quickly. Archosaurs, the ancestors of both crocodiles and dinosaurs, begin to diversify. Some are small bipedal hunters with agile legs and alert eyes. Others are larger, lumbering forms with thick scales and deep chests. Nearby, early therapsids, the mammal-like reptiles that survived the extinction, continue to adapt. Some begin developing whiskers, perhaps fur, better temperature regulation. They are not yet mammals, but their bones are shifting, evolving. Their teeth begin to differentiate, molars, canines, incisors, hinting at diets more complex than ever before. In the oceans, marine reptiles return in new forms. Ichthyosaurs, sleek dolphin-shaped predators, slice through the waves with remarkable grace. They give birth to live young and have large eyes adapted for deep-water hunting. Close behind, you find the long-necked plesiosaurs, with flippered limbs and a body built for underwater cruising. Corals are still gone, but reefs reform using different builders: sponges, bivalves, and other hardy organisms. Fish repopulate the waters. Plankton bloom. The oxygen returns. And then there are the ammonoids, cousins of the ancient nautilus, now thriving in elaborate spiraled shells. They are both predators and prey, and their diversity makes them valuable to modern paleontologists as time markers in the fossil record. You pick one up from the sediment. Its pattern is exquisite, its surface ridged and perfect. Back on land, ecosystems grow more layered. Insects reappear. Beetles, cicadas, early flies. Reptiles spread across the globe, occupying niches once held by amphibians and other Permian-era survivors. And then, something remarkable happens. You hear it before you see it. The swift, rhythmic steps of a creature running on two legs. Out from a stand of cycads bursts a small dinosaur, not the giants of later ages, but an early ancestor. It's no taller than your knee, featherless, lean, with sharp claws and a long tail for balance. Its eyes are bright. It hunts small lizards, insects, maybe even baby archosaurs. Its name might be Eoraptor, or perhaps Herrerasaurus, two of the earliest known dinosaurs. They are not yet dominant, but they are spreading. Fast, adaptable, and efficient. It is in these unassuming creatures that the seeds of the dinosaur age are sown. How did these dinosaurs come to rise above the rest? One answer may lie in the climate. The Triassic world, though recovering, is harsh. Long droughts, searing heat, and unpredictable rainfall create pressures that favor adaptability. Dinosaurs, with their upright limbs and efficient lungs, can move farther, breathe better, and regulate heat more effectively. They don't need to sprawl like lizards. They can walk and run with speed and power. Some scientists believe that their respiratory systems, perhaps similar to modern birds, gave them a huge advantage in low-oxygen environments. They could simply breathe better. And so, while other reptile groups plateau or decline, dinosaurs expand. But the Triassic is not without its own trials. Toward the end of this period, volcanic activity increases once again. The supercontinent begins to rift apart. Massive lava flows, the Central Atlantic magmatic province, spew into the air. Carbon dioxide levels rise. The climate warms further. Ocean acidification returns. And many of the early reptile lineages that had dominated the Triassic, particularly the crocodile-like pseudotsuchians, begin to die off. Another extinction occurs. Not as severe as the Permian, but still significant. And this time, dinosaurs are the ones who benefit. With their competitors gone, dinosaurs step into the open space left behind. They radiate across the globe, evolving into new forms. Long-necked sauropods, horned ceratopsians, swift raptors. They will dominate for the next 135 million years. But that is a story still to come. For now, the Triassic is a story of rebirth, of life rebuilt on a quieter, drier, more precarious planet, of strange reptiles and ancient forests, of small, unnoticed creatures that will one day become the rulers of Earth. And as you turn your gaze toward the horizon, you see a landscape beginning to change. The forest thickens, the heat turns damp, rivers grow wider, and life grows bolder. The Triassic world gives way to the next great act, the lush green stage of the Jurassic period. You awaken to the soft patter of rain falling through a dense green canopy. The air is thick with humidity and the earthy scent of wet leaves and moss. This is the Jurassic period, beginning around 201 million years ago. The world has grown warmer and wetter, and life, both plant and animal, is stretching toward the sky in ways never seen before. You step into a forest unlike any you've ever known. Towering tree ferns and coniferous giants arch overhead, their trunks wrapped in vines and thick with moss. The forest floor is quiet but alive. Scuttling insects, chirping early frogs, and rustling in the underbrush hint at life hidden in every corner. The Earth's warmth, driven by rising carbon dioxide and intense volcanic activity, has created a world of year-round lushness. No polar ice, no frost, just endless growing season. It is in this greenhouse world that life becomes immense. You feel the ground tremble, a low, rhythmic pulse that grows louder. Then, through the mist, emerges one of Earth's greatest achievements, a sauropod dinosaur. Its neck stretches above the canopy like a living tower. Its footsteps leave craters in the muddy ground. Despite its massive size, perhaps the length of a school bus or more, it moves with slow, deliberate grace, feeding on the treetops and leaving a path of rustling leaves behind. These are the giants of the Jurassic. Creatures like Diplodocus, Brachiosaurus, and Apatosaurus dominate the land. Their size is made possible by abundant vegetation, warm temperatures, and high oxygen levels. Their bones are light but strong. Their stomachs are vast fermentation chambers, and their hearts, some the size of oil drums, pump blood up towering necks with astonishing force. But they are not alone. In the open clearings and smaller forests, ornithopods, two-legged herbivores, graze in herds. Early stegosaurs patrol the ferns, their backs lined with bony plates that may serve for thermoregulation or defense. And lurking just beyond the trees are predators. You catch sight of one now, a theropod, perhaps Allosaurus, stalking through the shadow. It is swift, muscular, with forward-facing eyes and a long tail for balance. Its teeth glisten as it pauses, head tilted, listening. This is not a mindless hunter. It's a calculating, alert animal, finely tuned by millions of years of evolution. The Jurassic sky, too, is alive. Look upward and you'll see pterosaurs, the first true flyers among vertebrates, gliding effortlessly on wings made of skin and bone. Some are small, like modern gulls darting between branches. Others, like Rhamphorhynchus, boast long tails and leathery crests, cutting through the humid air above the forests and coastlines. And down in the oceans, life thrives in equal measure. Warm, shallow seas cover much of the continents. Coral reefs return, built by new species of corals and teem with fish, ammonites, and early marine reptiles. Ichthyosaurs still rule the open waters, joined now by plesiosaurs and pliosaurs, long-necked or broad-skulled marine reptiles that swim with powerful paddle-like limbs. You dive into one of these seas, gliding alongside a school of fish, only to spot a massive pliosaur in the distance, jaws wide, eyes sharp. It cuts through the water like a missile, hunting silently, its presence undeniable. The ocean floor is also teeming. Crinoids, brachiopods, shelled ammonites, all indicators of life's ongoing diversification. Back on land, Earth's continents are still joined, but they are beginning to split. The early stages of the Atlantic Ocean are forming, slowly pulling apart the supercontinent Pangaea into Laurasia in the north and Gondwana in the south. This tectonic movement reshapes coastlines, opens new seaways, and creates isolated environments where species begin to evolve separately. You feel the rumble of this slow tearing deep beneath your feet, the hidden engine of Earth's changes. The climate, warm and consistent, allows for stable ecosystems across wide regions. Seasons are gentle, rainfall is plentiful, flora and fauna spread easily. But this balance also comes with limits. Fires sweep through the forests occasionally, fueled by dry seasons and abundant plant material. And even in this thriving world, competition is fierce. Predators test the defenses of herbivores daily. Herds must stay alert, and individuals must adapt or vanish. You'd follow a group of juvenile sauropods along a stream. Their necks sway as they feed on low branches, their tails flicking flies. A predator watches from the shadows, but it does not attack. Not today. The young sauropods are too many, too wary. Tomorrow may be different. At night, the forest becomes a chorus of unfamiliar sounds. Croaks, screeches, low rumbles. Early mammals, small, nocturnal, insectivorous, scurry beneath the roots, surviving in the margins. They are quick, warm-blooded, and clever. And though they live in the shadow of giants, they are quietly preparing for their own rise. The Jurassic is a time of growth in size, in diversity, and scope. The land is blanketed in green. The skies are full of wings. The oceans roar with life. And yet, even this golden age will change. As the Jurassic draws to a close, the continents drift farther apart. New climates begin to form. Sea levels shift. And in the distance, a new group of dinosaurs, more agile, more feathered, more intelligent, begins to emerge. Cretaceous awaits. The warmth greets you like a thick, invisible tide. You've entered the Cretaceous period, the final chapter of the Mesozoic era, beginning around 145 million years ago and stretching to 66 million years ago. This is Earth at its most transformed, A greenhouse world where life reaches stunning heights of diversity and innovation. You walk through a dense forest unlike anything you've seen before. Gone are the towering conifers of the Jurassic canopy. Instead, broad-leafed plants rustle in the breeze. Flowers bloom in bursts of color, red, yellow, violet, attracting buzzing insects that dart from petal to petal. For the first time, Earth smells sweet. These are the angiosperms, flowering plants. Their evolution changes everything. With flowers come fruit. With fruit come pollinators, beetles, flies, wasps, bees, and seed dispersers. Birds, mammals, and dinosaurs that dine on sweetness and scatter seeds. The pace of evolution quickens. Ecosystems grow tighter, more interconnected. Specialization emerges. Symbiosis thrives. The air is heavy and warm, and the heat is not just tropical. Earth's poles, now free of ice, bloom with forests and ferns. Even Antarctica is temperate. There are crocodiles in the Arctic. Palm-like plants grow beneath summer sun that never sets. This is a planet without frost. You gaze at a map of this time. Continents have drifted far from their Pangean origins. The Atlantic Ocean is widening. North America is splitting from Europe. India is drifting northward toward Asia. New coastlines form. Shallow inland seas cover parts of the continents, including a vast one through the middle of North America, the Western Interior Seaway. These seaways teem with marine reptiles. Mosasaurus, the new apex predator, built like a torpedo with jaws wide enough to swallow a shark. Giant sea turtles paddle through open water, while ammonites, cousins of squid, drift and spiral through schools of fish. Back on land, the dinosaurs reach their evolutionary zenith. You spot Triceratops with its great bony frill and 3 sharp horns. It grazes in open meadows, watching warily as smaller predators circle. In the distance, a herd of Hadrosaurus, duck-billed dinosaurs, calls out in low, echoing voices, their nasal passages acting as resonating chambers. And then, through a clearing, steps Tyrannosaurus rex. Its massive head sways as it moves. Each footfall sends vibrations through the earth. Despite its bulk, it is fast, alert, and intelligent. Its eyes lock onto movement. Its teeth, each the size of a banana, gleam in the sun. This is not just a predator. It is the culmination of over 100 million years of carnivorous evolution. Feathers, once found only in smaller theropods, now cover many species. Some use them for insulation, some for display, and a few, like Microraptor or Velociraptor, may even glide or flap. Flight is no longer the sole domain of pterosaurs. Birds have arrived. You watch a small feathered dinosaur leap from a low branch. It flaps awkwardly, then glides, landing with a chirp. It's not quite a bird, but close. Nearby, true birds flutter and sing, primitive but unmistakably avian. Mammals too have diversified. They're still small, still mostly nocturnal, but they found their niches. Burrowers, climbers, insect hunters, some even begin forming complex teeth and specialized diets. They raise young in nests, they show signs of social behavior, they're waiting patiently for their time to rise. Even the insects are exploding in diversity. Ants form colonies, bees form hives, butterflies emerge with delicate wings. The world buzzes, clicks, and flutters with new life. Yet beneath all this abundance, change is coming. The same greenhouse climate that fuels plant growth also creates instability. High sea levels flood continents. Shorelines shift. Mountain building alters weather patterns. Volcanic activity in what is now India begins releasing gases into the sky, particularly carbon dioxide and sulfur dioxide, a foreshadowing of imbalance. You step now into the high Arctic. It's late summer. The sky glows with a golden light that never fully fades. Forests stretch in all directions, dense with conifers and flowering shrubs. Dinosaurs roam these polar regions, adapted to long seasons of darkness and light. Some may hibernate, others grow rapidly in spring. This is a world pushing the limits of adaptation. And then the sky shifts, not in the north, but far across the globe. A single event is on the horizon. 66 million years ago, an asteroid the size of a mountain hurtles toward Earth. It strikes what is now the Yucatan Peninsula in Mexico, releasing energy 1,000,000,000 times greater than the Hiroshima bomb. The impact vaporizes rock, sends firestorms across continents, and darkens the skies with ash. But that story is not yet here. For now, in this moment, Earth is alive in every sense of the word. It is green, teeming, loud, and vast. Dinosaurs of every shape and size walk the land. The oceans pulse with life. The air carries the scent of flowers and the buzz of wings. You pause, taking in the full glory of the Cretaceous, a world at its peak, unaware of what lies ahead. And as you turn your gaze toward the western sky, you feel the first distant tremble of a coming end. The warmth is still here, the life is still thriving, but the world is about to be changed forever. You are standing on the shore of a shallow inland sea. The air is still, thick with humidity. The sounds of the late Cretaceous surround you, buzzing insects, distant bellows of herbivores, the splash of fish near the reeds. Overhead, a sky full of pterosaurs glows with golden evening light. But then, silence. You look up. At first, it's just a streak in the sky, bright, fast, then blinding. A second sun. And then the sound, a deep, thunderous roar that tears through the atmosphere. The ground beneath your feet trembles, the air shifts. This is the end. An asteroid 6 miles wide strikes the Earth near what is now the Yucatan Peninsula. It crashes into the sea with unimaginable force, instantly vaporizing water and rock and sending a wall of fire into the sky. Shockwaves ripple through the crust. Earth itself rings like a bell. The immediate destruction is catastrophic. Tsunamis hundreds of feet tall sweep across coastlines. Forests ignite. The sky is filled with vaporized rock, soot, and sulfur aerosols. Molten debris rains down, setting the world ablaze. For hours, then days, the fires spread across continents. Carbon from burning forests chokes the air. Temperatures spike in the short term from radiant heat, but then the cooling begins. The particles thrown into the atmosphere block the sun. Days darken. Photosynthesis slows, then halts. The temperature drops. Global winter sets in. You wander through a charred forest. Ash falls like snow. The air is acrid, the light dim and orange, filtered through the high-altitude haze. Insects are silent. Flowers hang limp. Even the wind feels heavy, as if burdened by the weight of extinction. The impact marks the end of the Cretaceous and the end of the dinosaurs, at least the non-avian ones. It's estimated that over 75% of Earth's species vanish in the aftermath. Marine reptiles, pterosaurs, ammonites, forests collapse, food webs unravel. Herbivores die first. Without plants, they cannot eat. Carnivores follow. Oceans suffer from acidification and loss of oxygen. Plankton, the base of the marine food chain, falter. In a matter of months, the thriving world of the late Cretaceous becomes a graveyard. But beneath the ash, in the dark, life stirs. Some birds, descendants of small feathered dinosaurs, survive, perhaps by feeding on seeds or scavenging. Mammals, small and adaptable, burrow deep or take shelter in caves. Some amphibians, fish, and reptiles endure, aided by their low energy needs or aquatic habitats. You crouch beside a small rodent-like mammal. Its eyes are wide, twitching. It emerges only briefly to forage among the burnt foliage, then retreats to safety. It does not know it yet, but it will become part of the lineage that eventually leads to primates and humans. The world is hushed now. No more roars of T-Rex, no towering triceratops, no ammonites spiraling in the sea. But the Earth continues to turn. As years pass, the dust begins to settle. The sun returns weak at first, then stronger. Plants reappear. Ferns are the first, spreading rapidly across devastated landscapes. These disaster species colonize open ground, fixing nitrogen and rebuilding soil. Then come flowering plants again. Grasses begin to spread. Insects return. Pollinators, decomposers. With them, small birds flutter from tree to tree. Mammals diversify rapidly, filling niches once held by reptiles. It is a reset, a violent one, but also an opportunity. The extinction of the dominant forms of life opens ecological space, and into this space, evolution pours new experiments. Within just a few million years, a blink in Earth's time, forests regrow, oceans teem, and new animals begin to emerge. You walk now through a young Paleocene forest, thick with ferns and early flowering trees. A chorus of calls echoes through the air. Chirps, squeaks, rustles. Small mammals climb branches, scurry across the forest floor, and forage with clever paws. One of them stops to sniff the air. It has sharp eyes, a flexible spine, and a curious mind. Its kind will, in time, give rise to monkeys, then apes, then humans. The asteroid was not the end of life. It was the end of a chapter. Earth has experienced mass extinctions before, the Ordovician, the Devonian, the Permian. But this one is closer to us. Its crater still exists, buried beneath the Yucatan. Its dust still lies in a thin line in the rocks around the world, the iridium-rich boundary between the Cretaceous and the Paleogene. And its lessons still echo. The Earth is resilient, and so is life. But it is not immune to change. Climate, geology, and chance all shape the biosphere, and when they shift violently, life must adapt or vanish. From the fire and frost of this moment, a new era begins. One ruled not by reptiles, but by mammals. One shaped by cooling climates, rising mountains, and eventually, the footsteps of humankind. But before we reach that world, we must walk through the time of survivors and witness how life rebuilt itself in a cooler, post-dinosaur Earth. You wake to the gentle rustle of leaves in a forest not unlike those you know today, but softer, wilder, more ancient. The air is cooler, the light diffused through a canopy of flowering trees and thick underbrush. This is the Paleocene epoch, just after the extinction of the dinosaurs, around 65 million years ago. The age of mammals has begun. The world is no longer a greenhouse. Volcanic activity has slowed. Carbon dioxide levels have dropped. The continents continue their slow drift, forming new ocean currents. Polar ice has not yet returned, but temperatures are beginning to cool. Rainfall patterns shift. Landscapes evolve. And in this more temperate, less extreme climate, mammals seize the moment. You walk through a dense forest, its floor blanketed in moss and ferns. Small, fox-like creatures with long snouts scurry across your path. Overhead, lemur-like mammals leap between branches. These are early primates, agile, alert, with grasping hands and keen eyes. Their ancestors were tiny insect eaters, survivors of the Cretaceous extinction. Now they explore a world full of opportunity. You pause near a pond where a hoofed mammal drinks quietly. It's no larger than a rabbit, but it walks on elongated toes, the beginnings of what will become hooves. These animals, called condylarths, are the ancestors of deer, horses, and even whales. The Paleocene and Eocene epochs, spanning from about 65 to 34 million years ago, are periods of explosive mammalian evolution. With dinosaurs gone, new niches open up. On land, in trees, underground, and in the sea. The forests stretch across continents. Grasslands do not yet exist. Most creatures climb, dig, or walk beneath thick canopies. Insects are everywhere, pollinating the new wave of angiosperms, flowering trees, shrubs, and vines. Birds diversify, some ground-dwelling, others soaring. But the mammals are changing fastest of all. You cross a clearing and spot a large, bulky herbivore, something like a mix between a tapir and a pig. It grazes slowly, using broad teeth to crush leaves. It has few defenses, but few predators yet. Behind it, a strange creature stalks in the shadows, leaner, with sharp claws and forward-facing eyes. It's a creodont, one of the earliest mammalian carnivores. Back in the sea, the changes are just as dramatic. You dive into shallow coastal waters, where once marine reptiles swam. Now, new creatures have taken their place. Primitive whales, like Ambulocetus, the walking whale, swim with heavy limbs and wide tails. These mammals evolved from land-dwelling ancestors, returning to the water in search of food. Their ears adapt to underwater hearing. Their nostrils slowly shift toward the top of their heads. Evolution is sculpting something new. Further out to sea, early relatives of dolphins and sea cows swim through kelp forests. Marine ecosystems are reforming, rich with bony fish, crustaceans, and growing coral reefs. On land, mammals become larger. By the Eocene, about 50 million years ago, the Earth warms again briefly. Forests push into higher latitudes. Palm trees grow near the poles. Alligators bask in the Arctic sun. Rainforests span most of the globe. And mammals take full advantage. Some species reach enormous sizes. You pass a group of Uintatherium, thick-bodied herbivores with blunt tusks and bony knobs on their heads. Nearby, small horse-like animals called Hyracotherium nibble at low branches. They are the size of house cats, their toes still separate, their limbs built for forest paths. The air is richer in oxygen. Plant growth accelerates, animal metabolism quickens, mammals evolve better brains, better senses. Many begin forming social groups. Mothers care for young in dens and burrows. Pouches, milk, fur. All the quiet marvels of mammalian life flourish in this more stable, cooling climate. And then, a new kind of climate event begins. Continents continue to shift. The Indian subcontinent collides with Asia, pushing up the Himalayas. Mountain ranges rise elsewhere too, the Rockies, the Andes. These changes disrupt wind patterns, redirect rivers, and, most significantly, begin to alter ocean currents. In the southern hemisphere, the opening of the Drake Passage between South America and Antarctica allows cold water to begin circulating around Antarctica. Slowly, the first steps toward polar glaciation begin. Temperatures start to drop. You feel it in the wind. A sharper edge. A crispness that was not there before. Around 34 million years ago, at the boundary between the Eocene and Oligocene epochs, global cooling accelerates. Ice sheets begin to form at the South Pole. Sea levels fall. Tropical forests retract. Grasslands begin to emerge in drier regions. Forests fragment into groves and savannas. Mammals must adapt again. Some become runners, with longer limbs, fused toes, and lightweight skeletons. The ancestors of horses, antelopes, and camels appear. Others become diggers, jumpers, or grazers. Diets shift, brains grow. Predators follow prey into the open spaces, becoming faster and more cunning. You now stand in a landscape of change. Not crisis, but steady, relentless transformation. The climate is shaping bodies, minds, and behaviors. It is creating the stage for future evolution. Birds of prey circle overhead. Herds graze in the grass. Saber-toothed cats prowl the edges of woodlands. And deep in the trees, primates grow larger, more social, more intelligent. The earth is cooling, and mammals are rising, not just in number or variety, but in complexity. Soon, this changing world will challenge them further, with cycles of ice and fire. But in those coming trials, a new kind of intelligence will take shape, one that walks upright, shapes tools, and looks to the sky. But before we reach that age of humanity, we must pass through the long breath of glaciers and interglacials, the rhythm of the ice ages. A cold wind brushes your face as you step into the Pleistocene epoch, the most recent chapter in Earth's long story of climate and life. You're now just 2.5 million years from the present, and the rhythm of the planet has changed again. It no longer sways gently between warm and cool, but pulses in great cycles of ice and thaw, a breath that spans tens of thousands of years. These are the ice ages. Before you lies a vast northern landscape blanketed in snow. Towering glaciers, miles thick, crawl across continents like slow, grinding rivers. They've carved valleys, shaped mountains, and pushed boulders across the land like pebbles. Beneath their icy weight, the earth is bowed and silent. But this isn't a lifeless world. You follow a herd of Mammuthus primigenius, woolly mammoths, as they trudge across the frozen tundra. Their thick coats ripple in the wind. Their curved tusks gleam with frost, and their wide, padded feet grip the snow. They move slowly but steadily, led by a matriarch who remembers ancient paths now buried in ice. These ice ages aren't one long winter, but a cycle of glacial and interglacial periods, colder times when ice advances, followed by warmer intervals when it retreats. These changes are driven by subtle variations in Earth's orbit, tilt and wobble, the Milankovitch cycles, which alter how sunlight is distributed across the planet. You watch as glaciers spread during a glacial period. Sea levels drop, exposing land bridges between continents. Herds of animals migrate across newly connected lands. Camels to South America, elephants into Asia, humans into the Americas. The Earth's shape itself is transformed. Then the climate shifts. A warm interglacial begins. The ice melts. Seas rise. Forests spread into former tundras. Animals adapt again. Some move north, others vanish. Insects return. Flowers bloom. Rivers swell. But soon enough the cycle reverses, and the glaciers advance once more. It is a constant heartbeat. Freeze, thaw, and life flows with it. You walk alongside other Ice Age titans, the giant ground sloth, slowly dragging its claws through snow-covered ferns. The short-faced bear, massive and built for power, patrols the edges of a pine forest. Herds of bison thunder across a plain, their coats thick, their heads low against the wind. Predators thrive too. The saber-toothed cat lies in wait behind a ridge, watching a herd of grazing megafauna. Its fangs are long, but its legs are strong, built for sudden ambushes. Wolves, not like those of today, but larger and more robust, roam in packs, howling across icy valleys. And amidst all of this, you find something new. A figure crouched by a fire, shaping a stone into a sharp edge. Wrapped in fur, dark eyes squinting against the cold, this is a member of the genus Homo, one of several species of humans that begin to appear in the Pleistocene. Homo habilis, Homo erectus, and eventually Homo sapiens. Your ancestors. They don't just survive in the shifting world. They learn, they adapt, they migrate, build tools, control fire, and form societies. The Ice Ages don't stop them. They shape them. You stand now inside a cave where red ochre paints mark animals on stone walls. The firelight flickers. A handprint rests on the wall, the echo of someone who lived tens of thousands of years ago. Outside, reindeer cross a snowy plain. Inside, stories are being told. Humans spread across the earth during these cold cycles, from Africa into Europe, Asia, Australia, and the Americas. They follow rivers and coastlines, chase migrating herds, and settle in valleys between glaciers. Their brains grow larger, their tools more complex. Language emerges, and with them come changes to the land. Wherever humans go, they alter ecosystems, hunting, building shelters, lighting fires. Some large animals disappear, perhaps from climate shifts, perhaps from human pressure, or both. The mammoth, the giant sloth, the saber-toothed cat, many vanish near the end of the Ice Age. Still, the climate continues to fluctuate. About 11,700 years ago, the last glacial period ends. The current interglacial begins. Glaciers retreat dramatically. Temperatures rise. Forests reclaim the land. The Holocene epoch begins. The time in which you live today. You stand on a ridge as the last of the ice melts from a valley below. Rivers run strong again, lakes fill, birds return in flocks. Humans begin to settle, plant seeds, domesticate animals. Villages rise where glaciers once stood, and in the soil, the ancient bones of mammoths rest, wrapped in silence. The ice ages left more than scars on the land. They carved paths for rivers, created soil from pulverized rock, and shaped migration routes. They shaped you, too, your body, your tools, your culture. In adapting to the cold, your ancestors learned cooperation, invention, and resilience. And yet, the climate's breath has not stopped. Even today, glaciers remain on high mountains and at the poles. Ice cores drilled from Antarctica still hold the layered story of 1,000,000 years of Earth's breathing, of warmth and cold, life and loss. You take one last look at the tundra, now thawing, and listen to the melting drip from a glacier's edge. The air is still cold, but the wind carries warmth. Ahead lies the age of civilization, of agriculture, cities, and science. But behind it all, the rhythm of Earth's ancient climate continues, shaping each new chapter in subtle, powerful ways. You now walk among people, not so different from yourself, gathered beneath a warm sun, tending crops in a wide green valley. The year is somewhere around 10,000 BCE. The last great glacier has melted, rivers run freely again, and Earth has entered a rare, stable phase, the Holocene. This moment of stability changes everything. For hundreds of thousands of years, your ancestors have moved with the rhythms of the climate, shifting from place to place, hunting mammoths, gathering roots, building temporary shelters. Now, for the first time in human history, the climate holds steady long enough for something new to flourish. Agriculture. You feel the stillness of the morning as farmers scatter seeds by hand. They do so with trust that the seasons will return as they did last year and the year before. The rains will come, the sun will rise, the crops will grow. Wheat, barley, millet, and rice, these humble grains begin to bind human societies to the land. Settlements grow, villages become towns, people begin to store food, build homes, raise children in one place. With food security comes time. Time to make pottery, weave cloth, build temples, and pass down stories. Climate has allowed this, not by being warm or cold, but by being predictable. Yet even within the Holocene, the climate is never entirely still. You wander through a region near what is now the Middle East, Mesopotamia. The land here is fertile, between two great rivers, the Tigris and Euphrates. It's called the Fertile Crescent, and here, some of the first cities rise: Uruk, Eridu. But rainfall fluctuates. River floods can be blessing or curse. Droughts come in cycles, sometimes lasting years. The climate is not your enemy, but it must be understood. Ancient people begin to track the skies, the stars, the sun, the flood cycles. Calendars are born. Gods of rain and harvest are worshipped. Further east, in the valleys of the Yellow and Yangtze rivers, early Chinese civilizations grow rice and millet. Monsoons bring seasonal rains, but too much or too little can tip the balance. Climate influences everything from planting schedules to dynastic rise and fall. In the Andes and Mesoamerica, ancient peoples develop agriculture in mountains and jungles. The Maya, the Inca, their cities flourish in climates they learn to master. They carve terraces, build aqueducts, measure solstices. Yet when prolonged droughts strike, as they do in the 9th century CE, cities collapse, populations migrate, and cultures transform. You pass through Africa's Sahel, the semi-arid borderland between desert and jungle. Here, great lakes once shimmered, teeming with fish. But over thousands of years, as rainfall patterns shift, the lakes shrink. The Sahara itself was once green, dotted with trees, giraffes, and hippos. But slowly, it dries. The people of the region move, following the rains, shaping the migrations of cattle, cultures, and languages. In Europe, the medieval warm period, from roughly 900 to 1300 CE, brings milder winters and longer growing seasons. Grapes are grown in England. Populations rise. But then the Little Ice Age creeps in. Between the 14th and 19th centuries, Winters grow harsher, rivers freeze, harvests fail, famine spreads. The Thames in London hosts frost fairs. Iceland's coastal settlements struggle. In North America, indigenous agricultural societies must adapt as climate tightens its grip. Even the timing of the French Revolution, some argue, was pushed along by failed grain harvests and hunger linked to cooler, volatile weather. And then, something unprecedented begins. You're standing in England in the late 1700s. Smoke rises from chimneys, machines clatter in factories, coal, dug from the ground, powers furnaces, engines, locomotives. The Industrial Revolution has begun, and with it, humans begin to influence climate, not just by adapting to it, but by changing it. The carbon long buried in the swamps of the Carboniferous is being burned. Carbon dioxide, invisible but potent, accumulates in the atmosphere. It traps heat. Slowly, the balance tips. By the 20th century, scientists begin to measure rising temperatures. Glaciers retreat. Sea levels inch upward. Heat waves grow more intense. The rhythm of Earth's climate, once guided solely by orbital wobbles and volcanic pulses, now hears a new beat, added by humans. You glance at satellite images, the Earth from above. Forests shrink, deserts expand, coral reefs bleach, storms intensify, the Arctic melts. It is not the most extreme shift in Earth's history, but it is the fastest. And for the first time, one species is both the cause and the witness. We are not helpless. You walk through a solar farm shimmering in the desert sun. Wind turbines turn across grassy plains. People plant mangroves, restore peatlands, rethink cities. Indigenous communities revive old water-saving knowledge. Scientists model the climate using supercomputers. Youth march in the streets. Farmers test drought-resistant crops. We are still in the Holocene, or perhaps its successor, the Anthropocene. And climate remains our quiet companion, shaping not only our survival, but our decisions, our stories, our future. The dance continue. You look ahead and see a world in motion, not fixed, not doomed, but alive. Just as glaciers shaped valleys and volcanic eruptions warmed the air and orbital changes sculpted ice sheets, now human choices add a verse to the song. And as the world warms once more, we face the challenge, not only to adapt, but to understand, remember, and act. In the final chapter, we will look back and forward and ask what the great climate shifts of the past can teach us about the fragile, powerful Earth we call home. The wind that brushes your skin today is the same wind that once swept across ancient glaciers, rustled through Carboniferous forests, and carried volcanic ash after the Permian extinction. It carries with it more than moisture or warmth. It carries memory. You're standing in the present, but surrounded by echoes. From the molten seas of Earth's birth to the icy silence of Snowball Earth, from the humid Devonian swamps to the fiery skies of the Cretaceous impact, from glacial pulses to human-led warming, climate has never stood still. And now, as you look around your modern world, you see that we are part of that same continuum. Skyscrapers stand where mammoths once roamed. Farms thrive in regions once buried beneath ice. Cities glow in deserts that were once seabeds. We live on landscapes shaped by ancient climate shifts, and we carry the consequences of those changes in our bones. Our lungs evolved in oxygen-rich air made by cyanobacteria in Precambrian oceans. Our bones descend from fish that once swam through warm Cambrian shallows. Our minds, curious, calculating, storytelling, were shaped by the trials of the Ice Age. The climate is not just background, it is a character in Earth's grand story, sometimes gentle, sometimes harsh, always powerful. Today, we face a warming planet, a new chapter in this ancient saga. Global average temperatures are rising faster than at nearly any point in the geological record. Glaciers are melting, oceans are expanding, weather grows more extreme. Ecosystems shift, species migrate, some vanish. And unlike past episodes, this change is being driven by one species, us. By burning fossil fuels, Clearing forests and altering the chemistry of the air, we've become agents of planetary transformation. Our carbon emissions have pushed the Earth into a new thermal regime, one not seen since the warmest parts of the Eocene. Yet it took tens of millions of years for that warmth to build naturally. We have triggered it in just a few centuries. The lessons of the past are not warnings carved in stone. They are living messages, still relevant. Snowball Earth shows how delicate the climate can be, how a small change can spiral into global transformation. The Permian extinction reminds us that rapid warming can destabilize ecosystems and collapse biodiversity. The rise of forests teaches us the power of plants to cool the planet, while the ice ages show that even slow orbital wobbles can reshape continents and life. But these chapters also teach resilience. Life rebounded from extinction. Not always the same, but always evolving. Ecosystems adapted, species emerged, intelligence formed. And in humanity, Earth produced not just a survivor, but a species capable of reflection. You, who can look to the stars and the soil, who can measure carbon in bubbles of ancient ice, who can recognize the fingerprints of past climate in tree rings, coral reefs, and sediment layers, who can make choices not just for survival, but for stewardship. And yet, even now, the climate continues to whisper its age-old rhythm. You walk through a modern forest. The leaves shimmer in warmer than usual winds. A stream runs low after a dry season. A butterfly arrives earlier than expected. None of these signs scream catastrophe, but together they speak of change, subtle, accumulating, undeniable. Still, hope remains in knowledge and action. The past reminds us that climate is not static, that Earth endures, that life adapts. But it also reminds us that change can be swift and loss permanent. We are the first species to witness climate history and hold the power to change its future. As you take one final breath of the present air, you feel not fear, but awe. You are part of a story 4.5 billion years in the making. A story shaped by fire, ice, bloom, collapse, and renewal. You walk in the footsteps of trilobites, dinosaurs, glaciers, and forests. And ahead of you, the path unfolds. How it continues is up to us. Hello again, dear listener. You've traveled far tonight, across frozen seas and fiery skies, through jungles of ferns and valleys of ice, alongside mammoths and dinosaurs, early primates and ancient trees. You've walked through the deep rhythm of Earth's climate, a quiet, pulsing force that has shaped everything we see, touch, and are. We began in silence, when the planet was locked in ice. We warmed with the Cambrian seas. We soared through Jurassic forests and dove into Cretaceous reefs. We witnessed the fall of giants, the rise of mammals, and the footsteps of humans across an ever-shifting Earth. And at each turn, climate was there, not as a distant backdrop, but as a living force, patient and powerful. What you feel now, the winds outside your window, the warmth of summer, the chill of a morning breeze, is connected to that ancient breath. The past lives in the clouds, in the layers of rock, in the quiet patterns of trees and tides. It lives in you. So rest now, knowing that you are part of this great unfolding. That your story is braided into Earth's own, shaped by the same forces that once carved glaciers and fed towering ferns. And as you drift into sleep, remember, the story of our world is always unfolding, even in dreams. And as you drift into sleep, remember, the story of our world is always unfolding, even in dreams.